Okay, so I guess we can start. Welcome everyone to the Women in Network Science seminars. Today, I'm very happy to introduce Ariadna Fosch. She's from Barcelona. She studied biomedical engineering at the University of Pompeu Fabra and system biology at Maastricht University. And now she's doing a PhD. She's at the third year PhD in physics at the BIFI Institute, which is part of the University of Zaragoza. And she's also a PhD researcher at the Centai Institute in Turin, in Italy. She works at the intersection between complexity, science, and sustainability from the perspective of the Sustainable Development Goals. And yeah, if you want to share your screen, I leave the floor to you. You have 40 minutes, something, and then there will be time for questions. If people want to also start asking questions, I will take a look at the chat, but yeah, you can start. Thanks for coming.
Cool. Well, thanks for inviting me, actually. I'm gonna share my screen. Okay, you should be able to see the presentation now, right?
Yes.
Perfect. Okay, so yes, I was saying thanks, Elena, especially for inviting me here to participate at the seminars for the Women in Network Science Society. And when I was thinking about what to present today, I thought that it might be a good fit for this study that I did in collaboration with a very large group of co-authors, which was really like a pleasure to work with. And this work is about palm oil production and trying to see the impacts of this crop, which, as you may know or may not, but it has been like severely criticized for its negative impacts, but trying to go like a bit of one step further, not only focusing on seeing what are the impacts of this crop as a general thing, but also trying to see what are the differences between different production systems. Because in the end, and as I will try to develop during this whole talk, is not only the crop who may be like demonized or not, it's also like how do we produce it, who may have like a severe impact on the sustainability outcomes of this production system. So when I was thinking about planning the talk, and given that we have like an extended period of time, so 40 minutes, I considered that it may be also interesting to go one step backwards and not only focus on my study and the differences between industrial and smallholder palm oil and the SDGs, but also to provide a bit of a broader introduction to why it's interesting to study vegetable oils, so the sustainability of palm oil also, and different like vegetable oil production systems. So let's start by the beginning. So why are we interested in vegetable oils? So to start with, if we consider them from an economic point of view, it is true that vegetable oils are covering 1/3 of all the area that is dedicated to vegetable crops, which is a lot if you consider it in terms of worldwide area. And if you think in terms of economic value, they actually are around $262 billion. So to $62,000 billion economy, which is a lot. That's from the economic point of view. And then besides this, if you consider vegetable oils and fats more in particular, from a nutritional point of view, they are actually a very important aspect of our diets. So the World Health Organization recommends that healthy adult diets should have between 25 and 30% of calories coming from fats, which most of the fats that we eat or ingest are actually acquired from vegetable oils or other animal fats, but mostly vegetable oils. Actually, vegetable oils not only are important for diet, also have a numerous amount of uses. So for example, in cosmetics, it is very extended and very known, the advantages of oils for your skin, and also are used as the base for making cream and other types of cosmetic products, perfumes, and and all others. They are also part of animal feed, and this is also a very large amount of oil that is dedicated for this type of uses. Another type of uses, making soap and other chemical products that have a base in vegetable oils. And last but not least, one of the actual uses that it's gaining a bit more momentum in the last years is actually the use of vegetable oils for biofuels. This is still very, very much on the early stages of development, but just by seeing all these uses and also the rise of biofuels, give us an idea of all the uses and future needs that vegetables will have. Looking a bit at the future and the future perspectives, there are studies that expect that by 2050, there will be a 40% increase on the demand of vegetable oils. So if we look also at the projections in the last years, there's been an explosive increase on the demand of vegetable oils. And this actually presents an important question and an important problem that we have to address, which is how can we actually try to meet these demands for continuing, if we are truly interested in continuing human development to the current rate. How can we meet these demands in the most sustainable manner possible? This is a very complicated and complex question that not only involves studying single oils. As we can see, there are many different oil crops that can be used to produce vegetable oils, and all of them could be the solution, or could be favored in terms of trying to meet these global demands. So here we have some drawings of different vegetable oils. So as I was saying, maybe you know some of them, maybe you don't. But the question is, okay, we want to meet this increasing demand on vegetable oils in the most sustainable way possible. Which oil would we prefer in general? It's a tricky question because they all have very much different properties. So from the consumer point of view, there's differences in the smells and flavors of these oils. Also, depending on the use that you want to give them, they have different chemical compositions, so different ratios between saturated and unsaturated fats. So they may be better for different uses, different melting points, which make them also burn at different temperatures. But then this is only from the consumer side. If we look at the production side, which is where we are interested in terms of seeing what could be the future oil that could be essentially the one that we would want to prefer in a way, we see that essentially these things started to get more tricky. So different oils have different yields per hectare, so they will have different production rates, and they are produced in different areas of the world, which also involves many different issues in terms of the commercial preferences and socio-political preferences. So as we were saying, in general, different types of vegetable oils can have different impacts in terms of the production. And that's something that we truly have to take into account when essentially deciding what we want to do, use more for or prioritize towards making sustainable production choices. So we are now going to focus a bit more on palm oil, and here is where the controversy starts. So essentially, palm oil has been severely criticized, also for its negative, especially for its negative environmental impacts, as it's been associated with deforestation and negative influx for especially rainforest. But one of the things that is least known is that, in fact, palm oil is currently the vegetable oil with the highest production, and it is one of the oils with also the lowest demand of land. So essentially, the yield of oil per hectare is actually really high. This is an important consideration when trying to plan and strategize for sustainable approaches for vegetable oil production, because if we truly deem that the palm oil is actually too negative for the environment to use, we would actually have to replace it with some other oil. And here is where the thing gets tricky, because we know the current impacts of palm oil, but we don't know actually the impacts of replacing it by some other oil if we actually would want to do that. For example, if we were to choose the second option, which would be soybean, the second most produced oil, this would require a much larger amount of land, which will then have some other negative impacts that will have to be, for the environment, for example, that will have to be considered. And even in some cases, it would be impossible just by the sheer amount of land needed. So it's important to get all of these perspective in common, and then get a more systemic point of view towards planning the future of vegetable oils in general. So this was a bit of an introduction to see that it's not a trivial task to say an oil is good or an oil is bad. There are more nuances to it. But where is the controversy coming from? Because that's something, the controversy around palm oil, it's something that is also very much linked to certain areas of the world, and it's very cultural. There's, for example, local regions where they use palm oil traditionally on their recipes, that they consider it to be a very healthy crop and a very healthy option for their consumption, while in especially Western countries, it's been more demonized. So, as I said, palm oil is the most produced vegetable oil globally, and it's true that it has been linked to deforestation in the humid tropics. But at the same time, some other researchers have identified that it has been a good driver for socioeconomic development in Indonesia, Malaysia, which are the main producers of this oil. So essentially, there's a bit controversy. The controversy also has been amplified a lot by social media. So one of the main driving points of this, the controversy around palm oil was a campaign made by Greenpeace, say against Nestlé, in which they argued that essentially palm oil was destroying the rainforest and killing orangutans, and they made a video on YouTube just to explain this idea and criticize Nestlé. The thing that happened later is that this video got then an overwhelming response on Twitter, the now newly named X social platform, which in the end, the whole pressure and the global campaign resulted in Nestlé having to take some action. So, for example, they suspended the purchases from their providers and had to join some sustainability initiatives, and promised a full analysis of their supply chain in return. So we see that the controversy of palm oil has been very much linked to social media from the start. And I wanted to present also this study also from Elena, who is also present here, in which they studied the global perception around vegetable oils in general, seeing what are the oils that are most spoken about on Twitter. So on the first plot, what they saw was that there are three main oils that are by far the most commented about in the last years, which are coconut oil, olive oil, and palm oil. So from this plot, what the idea is that there's also the start of the palm oil trend started also around 2010, precisely from that tweet. And then they wanted to see what is the also sentiment. So how are people talking about those oils? If they are talking with good words or more harsh messages, and what is the sentiment associated to it. Before entering into the sentiment part, I want to present this, which was a bit related to the idea of what I was saying before, in terms of palm oil is mostly spoken, at least in Twitter, on the narrative is very much dominated by Western countries, and in a smaller amount by some producing countries. But this also has an influence in terms of seeing what is the actual messages associated with oils. So we can see that essentially palm oil is the oil it's associated with words like killer palm, palm oil kills, the orangutans, deforestation, while the other oils have a much more positive connotation, even when like coconut has also been linked to, in some other studies, to deforestation and other types of negative environmental effects. The interesting thing is that now, okay, we see the perception. Let's try to see what is the some studies. So what are they showing of the actual impacts of palm oil plantations on Indonesia in this case? So this comes from a study by Shantika et al., in which they studied the impact of palm oil plantations and compared the impact of these on socioeconomic and socioecological indicators when palm oil is produced through a traditional approach or an RSPO certified approach. So the RSPO certification is a certificate for sustainable palm oil production, which essentially is the one that the European Union, for example, is now promoting right now, saying that they will only want to consume certified palm oil. And the idea is that they also compared, and that's a very important point, differences between what was the prior state of the village before and after palm oil production. So if it was a village that was relying on subsistence from the forest, or it already had a market-based economy. What we can see is that in this case, there are differences. So the context of palm oil production actually conditions a lot the socioeconomic and also the socioecological impacts of the crop. So we can see that even in market-based economies with the certification oil, there's even positive impacts of having palm oil production. So it's not a black or white situation. It's not the crop, it's more on how do you produce it. So that was the idea that we wanted to start our study with, which was, okay, it's not the crop, it's how you produce it. So what can we say in terms of the impacts of palm oil production and sustainable development when taking this idea into account of we have different ways of producing palm oil. And in terms of, okay, how do you define sustainable development? The approach that we decided to focus on is the Sustainable Development Goals. So just in a few minutes, because I assume that most of you have heard about them, maybe you don't know what they are, but in 2015, the United Nations proposed this initiative in which it was an idea to encourage that all countries, all members of the United Nations try to aim for a better future and a more sustainable development approach. So the idea is that the Sustainable Development Goals present 17 ideal objectives that all countries should aim towards. So the idea is that all initiatives that countries do during before 2020 should always try to aim towards these goals. And the good thing about the Sustainable Development Goals is that they not only consider ecological approaches or ecological goals, but also like goals that embrace economic development, gender equality, global peace, and all other forms of development. So it provides like a holistic point of view of what is sustainable development. So in the case of palm oil production, what we were interested in seeing is, okay, from this perspective of the SDGs, what type of production system is better for across the different objectives of the SDGs? Is a smallholder palm oil more beneficial for the sustainable development of the local communities in Indonesia, or is better like in having industrial plantations? And also we wanted to compare like the different consequences of palm oil production in general. So to start with, like we cannot, of course, start from nothing. And that's why we started from a data set of data acquired from satellite imagery that essentially divided the village area for all the populations in the island of Sumatra in Indonesia in like the area that was classified, the area that has been used for different types of palm oil production. So in this case, we have, this would be an example of the type of images that are being used for the classification, and our data set will have essentially for all the different categories, the percentage of total area of the village dedicated to that type of use. So we have different types of palm oil plantations, and in this case, we have a smallholder and industrial, so from the type of the ownership. And then we have 4 different types of land status. So the first one would be young plantations that are still not productive, mature plantations that are the closed canopy. So essentially it's like the one that is already producing palm oil. Then the unproductive or damaged plantations. So essentially damaged plantations would be areas like that do not have been cleared. So they were forests, but now has been cleared for palm oil production, but are not now planted. And probably that means that they were cleared, planted, and then failed. And then we have unproductive areas, but that potentially have been replanted. So they are areas with a low land coverage that is not young plantations, but it was classified as unproductive land in a previous time point of the data set. We can enter into more detail about the data if someone is interested, but it's a combination of the 2 data sets from Gavot et al. And Descaldes et al. So this is for the palm oil characteristics. We go then now to the sustainable development goals or the socioeconomic characteristics. So in this case, we use some data for census data for Indonesia. So there is the PODES survey that essentially is a survey that is taken every year by all the mayors or the representatives in all the villages in Indonesia. And in this case, we took essentially the data for the region of Sumatra. And we have data for 25,000 Sumatran villages. This data contains general indicators about the socioeconomic status of the villages in general. And then it also contains more specifically some data about the environmental characteristics of the town. Like, for example, the level of pollution, for air, water, and other types of socioeconomic variables. Overall, there was some work on identifying from these socioeconomic indicators the ones that were actually more related to the SDGs. And in this case, we identified 21 indicators that were related to 6 different dimensions of development. And then we also combined it with 6 general features describing village characteristics, like the population, and other types of features like name and belonging to certain areas. So, okay, we now want to try to see the relationship between these socioeconomic variables and palm oil production. So for that, we decided to follow our regression approach. So we decided to focus on specific palm oil production profiles. And in this case, we defined 4 different production profiles. The first one would be active plantations, both from an industrial or a smallholder point of view. And these were defined as the combination of young plantations and mature plantations from a specific production profile. Then we decided to explore what are the differences also between active plantations and the ones that are unproductive. So for unproductive land, we define unproductive land as the combination of unproductive smallholder and unproductive industrial, and the same for the unproductive and possibly replanted. So these 4 production profiles were then explored through the regression analysis. But we do have a problem when dealing with spatial data and regression analysis, which is that essentially in a normal linear regression, we make the assumption that the independent variables are uncorrelated between each other and the errors will be normally distributed. This is not the case with spatial data, because as you can see, this is one of the variables in our data set. And I put the whole Indonesia in this case because it's more evident, but we see that in this case, there is a huge spatial correlation for this variable, which would violate the intrinsic assumptions of a traditional linear regression model. In that case, when the variables are spatially correlated, there's the option of using spatial regression models, which essentially introduce a term of spatial dependence. And the intuitive way of interpreting them would be that we say that the dependent variable will be not only dependent on its own characteristics or its own independent features, but also on the characteristics of the neighbors. And how do you define this neighboring relationship? So the easiest way to define neighboring relationships is to use networks in this case. So we can actually define an adjacency matrix between the locations. So in this case, I provided an example for Sumatra, but for provinces. So if we color the different provinces, we can build like an adjacency matrix by saying, okay, if two provinces share some common point in their borders, they will be considered neighbors. So from here, we can generate the adjacency matrix that then if we row normalize it, we would get a matrix defining the strength of the association with neighbors. So this is for provinces, but then what if we do it for villages? Then we get a network of this type, which is much more refined. So, okay, we now have a way of defining the relationship between neighboring areas. What type of dependence do we want to model? So here we'll have the traditional ordinary least square equation. And it actually has like three different terms that we can consider spatially dependent. So the first one would be that the dependent variable will be dependent also on also on a spatial term. So for example, this would be the example in which we consider that the areas with more palm oil and for a specific type will also be closer to other towns that are a high level of industrial palm oil, which makes sense also if you consider that the characteristics of that palm oil needs to grow will also be shared by multiple villages. Then there's the other option of saying that the independent variables, so in this case, our socioeconomic characteristics will also be dependent on space, which also is something that could be reasonable to consider. Since poverty, for example, it's known that there are more richer areas and more poor areas based on resources, for example, and this would be some characteristics that could be incorporated to the model. The last way in which the spatial term can be incorporated into spatial regression models is on the errors. And in this case, it's a bit more tricky to interpret, but the best interpretation is that the error is considering that there may be an observable that is not considered so there may be a variable that is not considered that has some spatial dependence and it's not being considered currently on the model. So these are the three types of spatial dependence that can be incorporated to spatial regression models, and they can be combined. So to generate like a whole family of spatial regression models. So selecting the type of model for the data can be done easily from several statistical tests. So based on the Lagrange multiplier, the likelihood ratio, and the Moore psi. I'm not going to enter too much into detail, but for our data set, we actually identified that the best models that worked for the data were the spatial Durbin model and the spatial Durbin error model. So these two models are actually considering a spatial lag, so a spatial dependence on the y variable, and then a spatial dependence on the x variable for the spatial Durbin model, which is a global spatial dependency model. And the spatial Durbin error model will be a more localized effect. So the output of this analysis in a traditional regression model would be a table with coefficients that tell us the impact of modifying one variable for the estimation on the dependent variable. So if we increase one, can be interpreted as a partial derivative. So if we increase one unit, this independent variable, it will have an X amount increase on the dependent variable. In the case of spatial regression models, since we have the spatial term, we would get as an output a whole matrix telling us if we modify a variable, this independent variable in this location, this will have an impact on the dependent variable of this location and their neighbors and the other location. So it would be a full matrix. So to get more general results and get an idea of an aggregate impact, what it's done is usually that is computed, you estimate the average of the impact of modifying. So you estimate actually the average direct effects, indirect effects, and the total effects, which would be the sum of the direct and the indirect impacts. So essentially, like this can be interpreted as in an equivalent way of the traditional OLS coefficients. And this is the thing that I'm going to show you now for our regression analysis, in which I focus only on the total impact for time constraints, actually. So this would be the outputs of, if we say, okay, these are the 4 regressions that we train using the amount of land as dedicated as unproductive land, possibly replanted, active industrial or active smallholder plantations. And then these are the significant features that the spatial Durbin model identified. So in terms of interpretation, what we can see, the first thing that we can see is if we focus on unproductive land, there seemed to be like that an increase on the so unproductive land is associated with more different types of crime, more cases of malnutrition, more cases of pollution, and more distance to primary schools. These indicators are negative for different SDGs. So for SDG 1, which would be the poverty reduction, for SDG 9 in terms of the access to certain infrastructure and facilities, and also environmental SDGs in terms of the pollution. Unproductive land still has some beneficial effects in some SDGs, though they are not unique for this type of plantations. So, for example, it has some more access to healthcare facilities, which could be a remaining from when it was still available. When it was planned, it had an increase on the healthcare access. It also has an increase on the credit facilities, which could be, again, like an increase in the infrastructures. What we also see is that overall, active plantations have a very distinct profile in terms of the poverty. So, for example, both industrial and smallholder plantation are associated with lower numbers of poverty letters. So poverty letters are letters that are given to families who do not have enough money to sustain themselves. And then this could be like in agreement with other studies that said that palm oil production has positive economic effects and also like some beneficial outcomes for sustainable development. Interestingly, there's also some differences between industrial and smallholder production systems from this point of view. So we can see that though the effects may be mixed, there's still some negative effects in terms of environmental impacts. There's a difference between industrial and smallholder plantations. So let's try to explore it a bit further. So in this case, what we wanted to see is, okay, like we have seen that unproductive palm oil seems to have the most negative impacts on the SDGs in general. But what if we could potentially like replant it? Like, what would be the preferred option? And in this case, what we see is that replanting unproductive palm oil could be achieved virtually, of course, by trying a counterfactual scenario assessment. So in this case, what we tried is replanting. We could try a counterfactual intervention in which we assess the impact of replanting all unproductive land in Sumatra, so with either industrial or smallholder palm oil, and try to see the differences in the SDGs of trying this intervention with both approaches. So for this, what we did essentially is like we focus on 7 SDG indicators associated with 6 different SDGs, and we use this as our dependent variable. And then we modified the land use variables as the independent features in this case to see exactly the impact of modifying land use in the different SDG indicators. If we try to do this prediction approach, what we actually get are these maps, which, for example, this is the outcome of replanting, changing unproductive land, so replanting unproductive plantation with smallholder palm oil. And this is what we would get only for the poverty letters, so the SDG 1 indicator that we chose. We can see that in this case, it has a positive effect. So replanting unproductive land had a positive effect for SDG 1. It reduced the number of poverty letters, but it's actually not very informative to see this map because we do not know the meaning of, is it a lot reducing 100 by 100 poverty letters, the number of letters in a village? Like, that is not very informative. What we actually want to know is if an intervention is actually affecting the well-being of a village or not. For that, what we see essentially, what we want to check is if by applying this intervention, our village will be deprived or not of this service. So an example would be if an intervention induces a decrease in the number of hospitals, for example, which was one of the variables that we actually considered, the number of healthcare facilities, and that would be actually a truly negative impact for that for that village, sorry. While if the village already has many hospitals, maybe that effect is negative, yes, but it wouldn't be truly impactful. So for that purpose, what we did is essentially like we used some thresholds to define highly positive and highly negative impacts. So essentially, like if the application of the intervention that we propose causes a change from a deprived state to a non-deprived state for an indicator, then this will be considered like a highly positive intervention because it's truly making a change in the village. While if this is only like a positive change but not causing a change in the deprivation threshold, then it would only be considered a moderate effect. The same for the negative cases. So we actually then obtain this type of plot in which we see here like the total amount of so the percentage of villages in which we applied the counterfactual intervention. So we actually applied some synthetic replanting of unproductive land and of all of its unproductive land, sorry. And then we saw like a positive effect, a moderately positive effect, a highly positive effect for both industrial and smallholder palm oil. So what we see in this case is actually very interesting because we see that, for example, yes, as we saw before, the poverty letters are improving if we replant unproductive palm oil. So SDG 1 would be improving if we are replanting unproductive palm oil with both industrial and smallholder plantations. But what we see is that there's a difference in the number of villages that have, for example, a high positive effect. So the effect seems to be higher in terms of if we replant with smallholder plantations than with industrial. In the case, there's also other more pronounced differences. In the case, for example, of SDG 3, which would be the access to healthcare, which we see that there's an increase in the access to healthcare if we replant with smallholder palm oil expansion, while in the case of industrial, there would be even a moderate negative effect association. Of course, this, in the case of the school access, so we see that it's one of the few cases in which industrial palm oil expansion seems to be associated with more positive effects than smallholder palm oil expansion. And in the case of junior high school difference, it seems to be negatively correlated for both cases. Interestingly, one of the most interesting features is like the forest coverage seems to be highly correlated, like more positively correlated for the smallholder expansion case than for the industrial expansion case. So we truly see that smallholder replanting of unproductive land could be more beneficial for the SDGs in overall terms. So I wanted to also like bring this quote here. It's not gold, all that glitters in a way. Because yes, it seems that unproductive, so smallholder profile would be the one preferred if you are applying this intervention of replanting. But what if we check who's the production system that is mostly associated with unproductive land on the first place? So we see that more than 72% of the current unproductive land is actually associated with the smallholder production systems. So it is important this may be an important limitation for proposing interventions for sustainable palm oil production, because the beneficial outcomes for the SDGs that we observed before of smallholder replanting would only be truly effective if, or truly observed, if we make sure that the plantations survive. So it's important to provide also with other supplementary interventions to make sure that the higher failure rate that seems to be observed in smallholder plantations doesn't cause the replanted areas to fail again. So this potential beneficial intervention has to be complemented with other supplementary strategies. So a bit of main conclusions that I want to give from my talk. The first one is that, okay, we saw that vegetable oil demand is on the rise, and it's important that we do not try to focus on trivial approaches of saying, okay, we have to increase production. It's important to try to find ways of doing it in a sustainable way. We saw also that different vegetable oils may be preferred by some people, and there may be like some trends towards what oils are good, what oils are bad, but it's a bit more complicated than that. We just cannot blatantly replace completely one oil by another without considering first all the whole scheme of the potential impacts that this change may have. In terms of my study, and more specifically, what we saw is that unproductive palm oil was even more detrimental than active plantations for different sustainable development goals studied. And it also seems that active plantations have both a mix of positive and negative impacts, but these ones differ a bit depending on industrial or smallholder production systems. So based on this information, what we tried to propose was, okay, an intervention for sustainable palm oil expansion could be replanting unproductive land, which was the most detrimental for the SDGs, with either industrial or smallholder palm oil. So we observed overall that smallholder replanting would be the preferred intervention, but it will have to be accompanied by other complementary strategies to ensure that these plantations that are being replanted actually are surviving and are not failing again, so we can guarantee the positive effects derived from the replanting strategy proposed. So that was all from my side. I hope I managed to stay more or less in time, and we have some time for questions. And thanks for listening.